Okay, this is for Pre-Calc, Chapter 1, Lesson 3. These are the basic functions and their graphs. So hopefully by the end of this, we can quickly identify the parent function by observing its graph. Now there are 12 of these that we're going to look at. Most of them are fairly easy to see, and you guys have seen them before. You just need to get reacquainted with them. The first one is y equals x, and obviously that's a line. And you can see there, every x and y value are the same. So that is y equals x. Y equals x squared is a parabola. The vertex is at 0, 0. Okay. The third one, this one, some of these are kind of new, but you can see here, this graph is the ln x graph, which is the natural log. Now, if you could see here, there is a vertical asymptote. Actually, I should probably just abbreviate that. So there's a vertical asymptote, okay, x equals 0. So this graph will approach the y-axis but never touch it. Y equals 1 over x. Here you have a vertical asymptote of x equals 0 and a horizontal asymptote of y equals 0. Okay, because obviously 1 over 0 is not good. You can't, that's undefined. And then 1 over any number is never going to be 0. So both x and y, we approach 0 but never touch. This is e to the x. Okay, remember, e is a number. Okay, we talked about that last year. E is approximately 2.72 yada yada yada. Okay, and this is an exponential function. Okay, this is an exponential function, which means the variable is in the exponent. Here's absolute value of x. As you can see, the v, the vertex, again, 0, 0. By the way, exponential function, horizontal asymptote, y equals 0. So again, this graph, this exponential graph, gets close to the x-axis but does not cross that axis. It's an asymptote. A random blank slide. All right, next, cosine x. This is one cycle. Actually, let's go back. That is not one cycle. Actually, it is one cycle. They don't have the pi's here. So that's one cycle of the cosine graph. Okay, notice, I want you to notice something. If I asked you, is the cosine graph bounded? Well, you would definitely say it's bounded above, okay, and you would definitely say it's bounded below. So this would actually be bounded, okay. Sine x. That's this graph right here below. So here's one cycle of, that's terrible tracing by the way. That's one cycle of sine. Now, same thing with the cosine graph. This is bounded. It's bounded up here and it's bounded down here. Step function. Okay. This is called y equals, now it says int, but int means greatest integer. Okay. So what that means is that from 0, I don't know if I can blow this up. Hang on. Nope, I can't. So from 0 to 1, all the numbers from 0 all the way up to 1, okay, the greatest integer is 0. Okay? When x is 0, we put a hole at 1. This needs to stop doing that. All right? Because the greatest integer at 1 is 1. So that means that point is right here. Okay? We'll talk more about this one in class. We'll go over it more in depth and I'll explain it a little bit more. But this is a step function, obviously, because the graph looks like you're going up a flight of stairs. That's why they call it step function. But we will talk much more about this. It's not a hard function to understand, but this graph is really small and it's hard for me to kind of get in there and show you where everything is. So we will definitely talk more about this one. Okay, it says 9 of the functions have domained the set of all real numbers. Which 3 do not? So which 3 do not have a domain of all real numbers? Okay, this one's all real numbers. At y equals x is good. Y equals x squared is all real numbers. The domains now. Now, y equals ln x. Okay, the domain is not all real numbers. The domain is actually all the x's greater than 0. Okay, so if we fast forward, y equals ln x is one of them. Okay, let's go back. Okay, what about 1 over x? 1 over x goes from negative infinity to 0 and from 0 to infinity. Because remember, 0 we cannot use in the domain. At x equals 0, this value is undefined. So the domain for 1 over x is all real numbers except 0. So we go back here, y equals 1 over x does not have set of all real numbers being the domain. Okay? We're good with the exponential function. X can be whatever it wants to be. Same thing for the absolute value. So all real numbers for both on the bottom. Random blank slide. All real numbers are good for cosine. All real numbers are good for sine. All real numbers are good for the step function. Okay? The third one is not listed apparently. So which 2 do not? So the 2 that do not have all real numbers are ln x and 1 over x. Now the best part is, it says the next part says one of the functions has domain the set of all reals except 0. Which function is it, and why isn't 0 in the domain? Well, we just said y equals 1 over x has a domain of negative infinity to 0 union 0 to infinity. Now, why isn't 0 in the domain? Because y equals 1 over 0 is undefined. That is an undefined value. And because that's an undefined value, that means that x equals 0 is a vertical asymptote. Okay? And because it's a vertical asymptote, that means that 0 can't possibly be in the domain. Okay? It says only 2 of 12 functions have points of discontinuity. Are these points in the domain of the function? Well, the first one is the y equals the greatest integer function. Okay? Now, if we go back and look at that, notice how, and I know it's hard to see, guys, and like I said, we'll talk about this more in class, but if you see the hole right there, right above the hole, oh, come on. That's annoying. Okay. So right above that hole is a point. So that means that that x value is a part of the domain. Yes, there's a hole below it, but it fills in on the top. Okay? So that we're still okay with the real numbers there. Okay? It is not continuous. It is not continuous because you have to make a hole and pick up your pencil and keep drawing the steps. So it's not continuous, but it does have all the x's for the domain. The other one, okay, the other one is y equals 1 over x again. Now, it's discontinuous at x equals 0, right? So the question is 0 in the domain? Well, no. 0 is not in the domain because there's no value for y at x equals 0. Whereas for the integer function, the greatest integer function, yeah, there's a hole. Let's just say there's a hole at 5. Let me show you. Whoops. Let's say, so 1, 2, 3, 4, 5. There's a hole at 5. But right above it, whoops. This is ridiculous. I hate that. Right above it is a filled in point. So while there's a hole at x equals 5, there's a filled in point above it at x equals 5. Actually, that looks like 4. Sorry. 1, 2, 3. Sorry, at 4. Like I said, these graphs are really small. Okay? So if the hole is filled in at some point, so the hole is filled in up top, that 4 is still a part of the domain. Whereas the 1 over x, 0 isn't in the domain, because if you put 1 over 0, it's undefined. 3 of the 12 functions are bounded. Which 3? Well, one of them is cosine x. One of them is sine x. Okay, we talked about those before. Now let's look back. Okay, cosine and sine are bounded. Above and below. It doesn't appear as any others, if there's any others. So once again, 2. I think there's another function that was mentioned that we're not going to talk about. I think that's the point. So definitely these two. 3 of the 12 basic functions are even. Which are they? Now remember, even is symmetric about the y-axis. So if you flip it sideways, it's the same. Well, y equals x squared is even, right? Parabola is always, well, y equals x squared is symmetric about the y-axis. There's one. Not this, not the ln, not the 1 over x, not e to the x. Oh, absolute value is even. Okay? Because again, if you flip the v sideways, it's still a v. And by the way, I should amend that. It's a v, and it's still symmetric about the y-axis. Even functions are symmetric about the y-axis. So the vertex has to be on the y-axis for you to be able to say it's even. Okay? Let's see. Is the cosine function symmetric? So if we flip that over, that appears to be the case. So cosine is even. Sine is not. If you look, sine is not. Because if you flip this first hump over, it looks like that, which it's not the case. It's down there. So sine is not even. So we have y equals x squared, y equals absolute x, y equals cosine x. Okay, we've done this before, guys. I'm not going to try to make this any harder than it is. We've done translations before, okay? So inside the parentheses is translation, okay? So x minus 3 is 3 to the right, plus 3 is 3 to the left, okay? So this is the parent graph in the middle, okay? This would be the minus 3, this would be the plus 3. I know that's opposite of how you would normally think of it, but think about it. If you put x equals negative 3 in here, negative 3 plus 3 is 0, 0 squared is 0. Points negative 3, 0. Here you go. Okay, that's the vertex. So inside the parentheses, we're talking translation, right or left. Outside the parentheses, okay, outside the parentheses, we're going vertical. Actually, let's go back here and call that horizontal. Sorry, I'm covering that up, but we're going to try to make this easy. It's a vertical translation, or shift, okay? So this 2 means up 2, this minus 2 means down 2. Hopefully you guys already know this stuff. Okay, shouldn't have to explain it that much. Helpful hint to remember the difference between horizontal and vertical. Think add to the y, go high, add to the x, go left. Okay, so that might be a little something, maybe that helps you remember what they are. Stretches and compressions, okay, all right. A fraction is a vertical compression. A whole number is a stretch. Okay, so in other words, here, let me write compression here. Again, pardon my chicken scratch. A compression, okay, a compression means, so if I have 1/4 x squared, and I plug 1 in, okay, my graph's going to be wider. The stretch makes it thinner. Okay? Compression means you're just pushing down on it, which pushes the parabola out wider. Okay? The stretch, you're taking the parabola and stretching it out. So it'd be like if you were grabbing the tops and you were just pulling, and as you're pulling it up, it's getting thinner. Okay? So fractions less than 1. It should say fraction less, get out of there. Less, what is this going on here? Less than 1. Then it's a vertical compression. If it's greater than 1, then it's a stretch. Reflections, okay? We know this, all right? If there's a negative in front of x squared, it's flipped upside down. Okay? We know that. We've talked about that. Okay? In the y-axis, okay, the variable x is negative. See, back here, it was just negative x squared and positive x squared. Here, if I have x minus 1 in parentheses squared, don't do that. Okay? If this x becomes negative x, then it reflects in the y-axis. Okay? So here would be the red, okay? And then here would be the blue. Okay? So here's the y-axis. Okay? Since x turned to negative x right here, that means that the black graph flipped over to the blue, over the y-axis. Okay, that's a summary. That's a summary of everything that means anything as far as the flips, the stretches, the shifts. Okay, last one, it says graph the function x minus 2 quantity squared. Okay, x minus 2 quantity squared. Well, the parent graph is x squared. Okay, so with the little room that I have, here is y equals x squared. Now, x minus 2 is in parentheses, so that means we are going to shift to the right 2 units. Now, what that means is that now the vertex over 2, get over here, this point right here over 2, this point right here over 2. So now my graph of y equals x minus 2 squared is right there. Now, on what interval is the function increasing? On what interval is it decreasing? Well, it's increasing from here up. So it's increasing from 2, that's a bracket, to infinity. It's decreasing, it's decreasing from negative infinity to 2. Okay, remember we go left to right. So we start here, we go down. So that's negative infinity to 2. From 2 to infinity, we increase. Is the function even, odd, or neither? Now, even means it is symmetric about the y-axis. Okay? Here's y equals x minus 2 squared. That is not the y-axis, so even is out. Okay? Odd, it would have to be symmetric about the y equals x line. Well, that's not true, so odd's out. So it's neither. Okay? Now, if you wanted to prove that, algebraically, here's what you do. So you have y equals x minus 2 squared. If you FOILed that out, so if this was x minus 2 times x minus 2, that'd be x squared minus 4x plus 4. Now, what if you plugged negative x in? So now you have negative x minus 2 times negative x minus 2. Okay, so negative x times negative x is x squared. Negative x times negative 2 is plus 2x plus 2x, and then negative 2 times negative 2 is plus 4. So that turns into, and boy, we are really using the whole slide here, aren't we? X squared plus 4x plus 4. So if I compare these, okay, remember, even functions, everything is the same. Numbers, variables, signs are all the same. Well, this negative sign and this plus sign are different, so it can't be even. If it was odd, all the signs here would be different. They're not. Only one of them is different. So odd is out, so it has to be neither. Okay? So that's how you'd prove it algebraically. Let's erase this. We have more questions to answer, kids. We'll just get rid of that. Sorry the video is running long, but there's a lot to talk about. Sorry about that. Does the function have any extrema? Well, it does have, right here, at the vertex. Okay, so we have a minimum at 2, 0. That's the vertex. That's the lowest point of the graph. Okay? How does the graph relate to its parent function? Well, we just talked about that up here. Okay? So we shift right 2 units. So it's the parent function shifted right 2 units. Okay? So that's hopefully a fairly simple example of the shifts. Okay? We've done shifts, we've done reflections. This should not be, hopefully not, new material to you. Okay? Last one, piecewise functions. A piecewise function is one that is broken up into pieces. So instead of having a single equation, it's broken up into different equations. Without a calculator, we are going to graph the piecewise function below. Now this isn't very hard, guys, okay? This is the interval -3 to 0. And they're bracketed because of those signs right there. So, in that interval, f of x equals x. So that's the same thing as saying y equals x. So at x equals -3, y is -3. At x equals -2, y equals -2. At x equals -1, I'm just plugging in the points. Now, when I connect those, I just connect the 4 points because I'm only plotting this line on this interval. Okay? Now, when I go to the next interval, f of x equals 2, this is the interval from 0 to 1. Notice the signs. It is not or equal to. So we have parentheses there. So here's what that means. So at x equals 0, y equals 2. There's a hole. At x equals 1, y equals 2. We connect those with a line. That's supposed to be a line. Those are very big. Okay? It's supposed to be a vertical line. Or horizontal line. Sorry. So this is y equals 2. That's what that means. Now, the last one includes 1, but not 4. And we're talking about y equals the square root of x. Okay? It shouldn't be -1. It should be +1. Okay, so I plug in 1. Square root of 1 is 1. So at 1, 1, there's a point. Notice there's a hole, but it got filled in below. If I plug in 4, I get 2. So here's 4. Now I put a hole at 4 because 4 is not included. Whoops, I shouldn't put it there. Point's 4, 2. Here we go. And this is a curve, so it goes like that. Okay, so you have a straight line, jumps up to a horizontal line, but holes are at each end because they're 0 and 1 aren't included. And then square root of x, the first hole gets filled in, but then this one does not. We can talk more about these in class, guys. I really apologize for the length of this. But there's a lot of stuff to go through, and it's not hard, but I wanted to make sure that you guys saw it. We can answer questions on this, obviously, in class. Okay? So make sure you fill this in. If you have questions, star the slides that you have questions on, and we can get those in class. All right? See you guys.